We begin our journey far from home. Look, a vast, spinning disk of light, a city of 100 billion stars. This is our galaxy, the Milky Way. It is a breathtaking structure of immense scale, a swirling collection of suns, planets, and cosmic dust. Each point of light you see could be a sun much like our own, and around it, a family of worlds. We are but one tiny household in this sprawling metropolis. Our solar system resides in a quiet suburban spiral arm, far from the chaotic, brilliant turmoil of the galactic center. It is here, in this peaceful corner, that our story begins. A story of life, of curiosity, and of a journey into the great unknown that surrounds us. From this vantage point, our sun is utterly insignificant. It is just another star among billions, lost in the crowd. And the Earth? It is a speck of dust, invisible to the naked eye. Yet on this tiny, fragile world, something extraordinary has happened. Life has taken hold. It has clung on through asteroid impacts and ice ages, evolving and adapting. And from that tenacious grip on existence, a unique consciousness has emerged. One that is capable of looking up at the vastness of the cosmos and asking the most profound questions of all. Where did we come from, and are we alone in this immense, silent expanse? This galactic neighborhood is not always peaceful. It is a dynamic and ever-changing environment. Stars are born in brilliant nurseries of gas and dust, their light pushing back the darkness for the first time. And stars die, some in spectacular, violent explosions that can outshine the entire galaxy. These events, these cosmic dramas, play out over millions of years. They are the engines of creation and destruction. They forge the very elements that make up our world, our bodies. We are, in the most literal sense, made of stardust. Every atom of iron in our blood was forged in the heart of a dying star, long ago. Our journey tonight will take us across this cosmic ocean. We will witness the birth and death of stars. We will explore the fundamental and sometimes paradoxical laws that govern the universe. We will travel not with a spaceship, but with the most powerful vessel of all, the human imagination, fueled by centuries of scientific discovery. We seek to understand our place in this grand tapestry, to pull at the threads of mystery and see what secrets unravel. So let us venture forth into the darkness between the stars and see what wonders await us in the profound and beautiful emptiness of space. In the life of our galaxy, there is no event more dramatic than the death of a massive star. It is a final, spectacular act called a supernova. For millions of years, the star has been a stable, shining beacon. It has fused lighter elements into heavier ones in its core, creating a delicate balance between the inward pull of gravity and the outward push of nuclear fusion. But eventually, the fuel runs out. The balance is broken. Gravity, the relentless force that holds the galaxy together, wins. In a fraction of a second, the star's core collapses under its own immense weight. The outer layers then come crashing down and rebound in a cataclysmic explosion. This explosion is one of the most powerful events in the universe. For a few short weeks, the supernova can shine with the light of billions of suns, briefly outshining its entire host galaxy. It sends a shockwave of energy and matter racing outwards into space at incredible speeds. This wave will travel for thousands of years, sweeping through clouds of gas and dust, enriching them with the heavy elements forged in the star's final moments. Elements like gold, platinum, and uranium are created in these cosmic fireworks. Without supernovas, the universe would be a much simpler and far less interesting place. There would be no rocky planets, and no life as we know it. Our region of the Milky Way is littered with the remnants of these ancient explosions. They are beautiful, ethereal clouds of expanding gas, like the famous Crab Nebula. These are the tombstones of stars that died long before our own sun was even born. We are living amongst the ghosts of a more violent, chaotic past. But these events are not a direct threat to us now. The nearest star, massive enough to go supernova, is hundreds of light years away. By the time its light and radiation reached us, it would be so spread out, so diffuse, that its effects would be negligible. It would simply be a new, temporary star in our night sky. And so, we can look upon these events, not with fear, but with a sense of profound connection. They are a vital part of the cosmic life cycle. They are the galaxy's way of recycling its material, of taking the ashes of a dead star and using them to build new stars and new worlds. The drama of a supernova is not just an act of destruction, it is an act of creation. It is the violent, beautiful process that seeded our corner of the universe with the very ingredients necessary for life. We are the children of these stellar explosions, living proofs of the universe's ability to create order and complexity out of chaos. The universe, it seems, has a secret twin, a shadow self. For every particle of matter, like the electrons and protons that make up you and me, physics tells us there must be a corresponding antiparticle. This is antimatter. It is identical to normal matter in every way but one. It has the opposite electrical charge. An anti-electron, or positron, is just like an electron, but it is positively charged. An antiproton is just like a proton, but it is negatively charged. It is a perfect mirror image world, a ghost haunting the very fabric of reality, a concept that seems to belong more to science fiction than to fact. So, where is all this antimatter? According to our best theories of the Big Bang, matter and antimatter should have been created in almost equal amounts. When they meet, they annihilate each other in a perfect burst of pure energy. This is the most efficient energy conversion known to science, a process that makes nuclear reactions look like a damp squib. The great mystery is why anything is left at all. A tiny imbalance, a slight preference for matter over antimatter in the first moments of creation, is the only reason we have a universe of galaxies, stars, and planets instead of just an empty void filled with light. Despite its rarity, antimatter is not just a theoretical concept. We can create it in tiny, fleeting amounts in our laboratories using powerful particle accelerators, and it is also produced naturally in certain cosmic events. Supernovas, the death throes of massive stars that we have seen, can produce a spray of these exotic particles. So can the violent regions around black holes. Our own galaxy is faintly glowing with the energy produced by the annihilation of positrons. It is a ghostly light, detectable only by our most sensitive instruments, a constant reminder of this other, hidden reality. But like those distant supernovas, this cosmic antimatter poses no danger to us here on Earth. It is created in such minuscule quantities and is so spread out across the vastness of space that it is incredibly rare for an antiparticle to ever encounter our world. The universe is a very empty place. The chances of a stray antiproton traveling across light years of space to hit our planet are infinitesimally small. And so, we can study this strange, ephemeral substance from a safe distance. It is another piece of the cosmic puzzle, a clue to the fundamental laws that govern everything, and a tantalizing glimpse into what might have been. For all of human history, we have looked to the stars and wondered, are we alone? Is this small, blue world the only place where life has taken root and blossomed into consciousness? Or is the universe teeming with other minds, other civilizations, perhaps even looking back at us and asking the same question? This is perhaps the greatest question we can ask. The answer, whatever it may be, would be profound. It would reshape our understanding of ourselves and our place in the cosmos. It would tell us whether we are a unique miracle or just one of many voices in a grand cosmic choir. To bring some structure to this immense question, scientists have imagined a way to classify hypothetical alien civilizations. It is called the Kardashev scale. It does not measure intelligence or benevolence, but something much more practical: a civilization's ability to harness energy. A Type 1 civilization, for instance, would be able to use all the energy available on its home planet. That includes all the sunlight, wind, and geothermal energy. By this measure, humanity is not yet a Type 1 civilization. We are, perhaps, somewhere around Type 0.7 on this cosmic ladder, with a long way still to climb. A Type 2 civilization would be far more advanced. it would be able to harness the entire energy output of its home star. This is a staggering amount of power, billions of times more than a Type 1 civilization. Such a society would be a true master of its solar system. It could perhaps build vast structures to capture starlight, or even move planets. Its technological capabilities would seem like magic to us. It could control its environment on a planetary scale, immune to the threats of climate change or asteroid impacts that might plague a younger civilization. And beyond that, a Type 3 civilization. A society so powerful, so advanced, that it can harness the energy of its entire galaxy. The sheer scale of such a thing is almost impossible for us to comprehend. It would command the power of billions of stars. Such a civilization would be, for all intents and purposes, immortal. It would be a galactic superorganism, its presence felt across hundreds of thousands of light years. Are such beings possible? Do they exist somewhere in the vast darkness between the galaxies? We do not know. But the scale allows us to dream, and to frame our search for life beyond Earth. How could a civilization possibly harness the entire energy of its star? It is a question that has captivated scientists and dreamers alike. One of the most elegant and famous ideas is the Dyson sphere. It is not, as is often depicted, a solid shell that encloses the star. Such a structure would be gravitationally unstable. Rather, it's more likely to be a swarm of many thousands, or even millions, of independent orbiting habitats and solar collectors. A vast, intricate web, spinning around the central star, drinking in its light and energy. A man-made solar system. Imagine what it would be like to live in such a structure. There would be no day and night as we know it, no seasons. The inhabitants would have a constant, reliable source of near-limitless energy. The inner surfaces of these orbiting habitats could be turned into worlds in their own right, with a surface area millions of times greater than that of their home planet. There could be continents, oceans, forests, and deserts, all existing on the inside of a spinning cylinder, held down by centrifugal force. It is a vision of a technological paradise, a way for a civilization to break free from the constraints of its homeworld. These structures, if they exist, might be one of the best ways for us to find evidence of advanced alien life. A Type 2 civilization would be hard to miss. A star enclosed by a Dyson swarm would behave very strangely. Much of its visible light would be blocked. Instead, the structure itself, warmed by the star's energy, would glow brightly in the infrared part of the spectrum. It would look like a star that is inexplicably, unnaturally red and dim. And so, astronomers have begun to search for these telltale signs, sifting through the data from our telescopes, looking for stars that just do not look right. So far, our search has come up empty. We have found some intriguing candidates, stars that dim and brighten in strange, unpredictable ways, but none have proven to be the smoking gun, the definitive evidence of a vast alien megastructure. Perhaps they are too rare, perhaps they do not last for very long, or perhaps no civilization has ever managed to build one. The silence from the stars is deafening, but the search continues, because if we were to find just one such object, it would change everything. It would be the first proof that we are not alone in the universe. For over half a century now, we have been actively listening. We have built vast radio telescopes, their dishes turned to the heavens like giant ears, straining to hear a whisper from the stars. This is the search for extraterrestrial intelligence, or SETI. The logic is simple. Any technological civilization, like our own, is likely to use radio waves for communication and radar. Some of these signals will inevitably leak out into space, traveling at the speed of light. If there are other civilizations out there, perhaps we can overhear their conversations. Perhaps they are even deliberately beaming messages our way, hoping to make contact. But the sky is silent. We have scanned countless stars, across a wide range of frequencies. We have listened for the telltale signs of an intelligent signal, a repeating pattern, a complex but non-random burst of noise, anything that stands out from the natural static of the cosmos. And we have found nothing, not a single unambiguous peep. This profound and unsettling silence is known as the Fermi paradox. The galaxy is ancient and vast. There has been plenty of time for life to arise and for civilizations to spread. So, as the physicist Enrico Fermi famously asked, "Where is everybody?" Perhaps the distances are simply too great. The galaxy is 100,000 light-years across. A signal sent from the other side would take 100,000 years to reach us. A conversation would be impossible. Even a signal from one of our nearest stellar neighbors would take years to arrive. And space is vast and three-dimensional. We would have to be listening to the right star, at the right frequency, at the right time. It is like trying to find a single needle in a haystack the size of a continent. Our search has only just begun. We have explored a tiny fraction of the cosmic ocean. Or perhaps, we are just not listening in the right way. Maybe advanced civilizations abandon radio technology as quickly as they discover it. Perhaps they use more efficient methods of communication that we cannot yet detect, like neutrinos or even gravitational waves. Or maybe, they have no desire to communicate at all. Maybe they are deliberately hiding, fearful of what else might be out there in the dark. The possibilities are endless, and each one is more tantalizing and more unsettling than the last. The silence itself has become a mystery, a puzzle that we are compelled to solve. The silence of the universe leads us to a dark and sobering possibility, an idea known as the Great Filter. This theory suggests that there may be a barrier, or a series of barriers, that makes it incredibly difficult for life to progress from simple, single-celled organisms to a spacefaring, galaxy-spanning civilization. Somewhere along that long evolutionary road, there is a hurdle that is almost impossible to overcome. Life may be common, but intelligent, technological life might be exceptionally rare, because almost everyone fails at one of the steps along the way. What could this filter be? It could be behind us. Perhaps the jump from non-living matter to the first simple cell is the hardest step of all. Perhaps the evolution of complex, multicellular life is the great challenge. Or maybe the emergence of intelligence and consciousness like our own is the incredibly rare event. If the filter is behind us, then we are one of the lucky few. We have passed the test. It would mean that we are special, and that the universe is ours for the taking. It would be a lonely, but hopeful conclusion. But what if the filter is still ahead of us? This is a much more frightening prospect. It would mean that many civilizations reach our current level of technological development. They discover science, they split the atom, they venture into space. But then, something always happens. Perhaps it is a self-inflicted catastrophe, like nuclear war or runaway climate change. Perhaps it is a natural disaster on a cosmic scale. Or perhaps there is some technology that is so dangerous, so inherently destabilizing, that it inevitably leads to self-destruction. If this is the case, then the silence of the stars is a warning. It is the silence of a graveyard. The empty sky tells us that no one who reaches our stage of development makes it much further. We are standing on a precipice, and we are about to face the same test that has destroyed countless others before us. Every new discovery, every new technology, could be the one that seals our fate. It is a chilling thought. It turns our search for extraterrestrial life into a search for our own future, and the silence we hear might be the sound of our own impending doom. And so, we are left here, on our pale blue dot, suspended in a sunbeam. We have journeyed across the galaxy in our imaginations. We have witnessed the awesome power of dying stars and contemplated the ghostly nature of antimatter. We have dreamed of cosmic empires and listened for their whispers in the static. And we have returned with more questions than answers. The universe, it seems, does not give up its secrets easily. The silence persists, and we are left to wonder about our own place in this grand, silent cosmic drama. Perhaps we are simply the first. In the long 13.8 billion year history of the universe, perhaps we are the first species to reach this level of consciousness, to look up at the stars and ask these questions. It is a lonely thought, but also a profound one. It would place a great responsibility on our shoulders. To be the sole guardians of consciousness in this vast expanse, the only voice that can speak for the universe. We would be the custodians of a fragile flame, tasked with keeping it alive and spreading it to the stars. Or perhaps the universe is simply too strange, too alien for us to comprehend. Perhaps we are like ants on a motorway, oblivious to the complex world of the humans driving past. Maybe alien life is all around us, but in a form we cannot recognize. Perhaps it exists in the plasma of stars, or the oceans of methane on some distant moon, or even in other dimensions of space-time. Maybe they have seen us and have decided to leave us alone, to let our young civilization grow and find its own way. A cosmic nature reserve, protected from outside interference. Ultimately, we do not know. We are left in a state of profound and beautiful uncertainty. We stand on the shore of the cosmic ocean, having waded only a few feet into its shallows. The great expanse of the unknown lies before us. The silence from the stars is not an answer, but an invitation. An invitation to keep exploring, to keep listening, to keep asking questions, and to cherish this one small, fragile world. Because for now, it is the only home we have. And in the vast, silent darkness of the cosmos, it is the only place we know where the universe has woken up and begun to wonder.